How do you apply statistical methods in bioarchaeology? Imagine piecing together a puzzle of the past using bones and artifacts. That's what bioarchaeologists do, and statistical methods are their tools to make sense of all those pieces. When scientists study human remains from archaeological sites, they gather a lot of data. This includes ages, sexes, health conditions, and even cultural habits. To interpret this information accurately, they turn to statistics. First, they start with simple descriptions. They calculate averages like the average age at death or the most common health issues. They also look at how spread out the data is using measures like standard deviation. This helps them see the general picture of the population they are studying. For example, if many individuals show signs of nutritional deficiency, it might suggest a period of hardship. They also use frequency counts to see how often certain conditions or artifacts appear in burial sites. These counts can reveal patterns in how people were buried or what items they used. Next, scientists use inferential statistics to test ideas or hypotheses. For example, they might want to know if males and females had different average heights. They can use tests like the t-test to compare these groups, or they might want to see if there's a link between burial goods and social status. A chi-square test can help determine if such relationships are significant. These tests help turn raw data into meaningful conclusions about past societies. More advanced methods involve analyzing many variables at once. Techniques like principal components analysis or discriminant function analysis help classify individuals based on multiple traits. This can show if certain groups share biological features or cultural traits. For example, it might help identify if a group of skeletons from different sites belong to the same population. These methods requiring careful handling of missing data because bones often don't survive perfectly. Sometimes, they use models that consider data from multiple levels, like individuals within a cemetery, to better understand population patterns. Bayesian statistics are also used, especially for dating. They combine radiocarbon dates with prior knowledge to create more accurate timelines. This helps archaeologists understand when events happened and how different populations interacted over time. Scientists use software like R, which is free and flexible, or programs like SPSS and Python for their calculations. These tools allow them to create graphs, charts, and models that make complex data easier to understand. In the end, applying statistical methods in bioarchaeology helps turn bones and artifacts into stories about health, culture, and society. It makes the interpretation more precise and backed by numbers, giving us a clearer picture of life in the past.